Hi, it's Mrs. Morat with help on today's assignment, Unit 4, Lesson 2. All right, in 1990, the value of a home is $170,000. Since then, its value has increased by 5% per year. So this is the price in 1990, and then increasing by 5% per year. So we have to figure out a couple of things. But before we get started, let's talk about what are we going to multiply by if it increases by 5%. So remember, we did this the other day. We take the full price, the full 100%, add 5% to it, and then divide it by 100 to make it a decimal. So 105 divided by 100 is equal to 1.05. All right, so we're going to use that 1.05 as our growth factor to answer the questions. All right, what is the approximate value of the home in the year 1993? So this was the value in 1990. This is 3 years later. So we could start with 170,000 and multiply by 1.05 3 times because it's 3 years later. Or you could have done that using an exponent. So when I put it into the calculator, I'm going to just use an exponent. 170,000 times 1.05 to the third is 196,000. 796 and 25 cents, which, we may or may not have the 25 cents. All right, next write an equation in function notation to represent the value of the home as a function of time in years since 1990. So that's going to be like years since 1990. So we would say, and we have to use T for that. So maybe I'm going to use V for value. In 1990, the value was 170,000. It increases by 5% every year. And now in the year 2020, will the value of the home be more than 500,000 if this trend continues? So I'll just check. 2020 is 30 years since 1990. So I'll use a T value of 30. And then I'll just calculate 170,000 times 1.05 to the 30th. And that is just over like $734,730. And so since that is more than 500,000, I am going to say yes. All right, number 2. The graph shows a wolf population which has been growing exponentially. What was the population when it was first measured? Well, that's going to be right here on the y-axis. It looks like 90. By what factor did the population grow in the first year? So here's, from 0 to 1, and it goes from, oh wait, that's not 90, it's 100, sorry. I was thinking it was counting by 10s, it's counting by 20s. And so here is the population after 1 year, and it's at 120. So by what factor did the population grow? I'm going to divide 120 by 100, and I get 1.2. Okay, and so then to write an equation for that, so initial amount, so we're using W equals, and then T is time. So the initial amount is 100, and it's growing by 1.2, and then every year, so an exponent of T for time in years. Number 3 is asking us to look at this graph and then find an equation that defines F and explain your reasoning. All right, so the first thing I need to know to write an equation is what is that initial amount? And so it looks like the initial amount, F of 0, right here, looks like it's at about 50. So I know the initial amount, and then I need to know what it's growing by. And I can choose any 2 sequential years to determine what the growth factor is. And so I'm going to choose just year 2 to year 3. Okay, any 2 sequential years would be fine. So this is 200, and this is 400. And so I just have to divide to get the growth factor. And obviously 400 divided by 200 is equal to 2. So my equation is F of T equals the initial amount times the growth factor, it's doubling, and then to the T. And I just chose to use T. I didn't have to use, I was just using T for time. Could have used X. We've just been using T, so that's why I put it there. But either way, you could have any variable there as your exponent. All right, on number 4, the equation F of T equals 24,500 times 0.88. Oh, this time it's decay. It's less than 100%. To the T represents the value of a car in dollars T years after it was purchased. So what is the 24,500? It's going to be the purchase price. And the 0.88 is what does it mean? Well, it means that it keeps 88% of its value. So value is decreasing. Think about it, by the other 12% that it would add up to 100. So the value is decreasing by 12%. Okay, what does F of 9 represent? It represents the car's value 9 years after it was purchased. Sketch a graph that represents the function f and shows f of 0, 1, and 2. Okay, so if we know our equation, we can just make a little chart for t and then f of t, because we need to know the values at 0, 1, and 2. Well, at 0, it's the purchase price, 24,500. And then I'm going to need to calculate the other 2. So 24,500 times 0.88, well, to the first is just, didn't need to be there. And then 24,500 times 0.88 to the second. All right, so we have 21,560. And then 18,972. And I'll just put the 0.8 there. It doesn't need to be there. All right, so on our little sketch, we would have this is time. And then this is the value of the car. And if we kind of just estimate, here's 1 year, here's 2 years. And then maybe I would just like go up here and count by 5,000s. So 5,000, 10,000, 15,000, 20,000, 25,000. So 24,500 might be about here. 21,560 would be just above 20,000. And then 18,972 would be about here. And it's kind of make it a little bit curved. I'm not the best at drawing without an actual graph, but something like that. Okay, and it should just be a curve. Number 5, the first two terms of an exponential sequence are 18 and 6. Well, they're the next 3 terms of the sequence. All right, so to get from 18 to 6, 18 to 6, you divide by 3 or multiply by 1/3. And so this next one would be 2, and then 2/3, and then 2/9. All right. So you could repeatedly divide by 3, but what we really want to focus on is multiplying by 1/3, or using an exponent in the bottom. So you could go 18 divided by 3 to get the 6, and then divided by 3 to the second to get the 2, and then divided by 3 to the third to get the 2/3. There's lots of ways you could represent this, but probably dividing by 3 each time is what's going to be easiest just to generate the sequence. Okay, number 6. A bacteria population has been doubling each day for the last 5 days. Doubling each day for the last 5 days. Kind of like the pond problem from the other day. It is currently 100,000. What was the bacterial population 5 days ago? Explain how you know. So I would just make an organized list and go backwards. So 100,000. So if it had been doubling for 5 days, then the day before, so this is going to be 1 day before would be half of that, 50,000. And then the day before that, half of that is 25,000. See what's going on here? So this is 1 day before, this is 2 days before. So keep cutting it in half till you get to this day, the 5th day before. All right, so half of 25,000 is 12,500. Half of that is 6,250. And half of that is the answer we're looking for on day 4, which is 3,100, or day 5, 3,125. Okay, finally, we're going to be looking at number 7. Select all expressions that are equivalent to 27 to the 1/3. So we can represent 27 to the 1/3 as the cubed root of 27. And then the cubed root of 27 is equal to 3. Okay, so we would not select A. It's equal to 3, not 9. So definitely select B. And then it's not the square root of 27, it's the cubed root of 27. So D, not C. And then moving down a little bit more, you could represent 3 to the third as 27. So since 3 to the third equals 27, this also shows the cubed root of 27, which is equivalent to 27 to the 1/3. And these, there's not a negative exponent here, so no fraction answers. So B, D, and E. So that is the end of the assignment. I hope that the video was helpful.